Are we close to once again breaking the sound barrier in civilian flight? From the National Business Aviation Association, this is Flight Plan. I'm Pete Combs with your trusted source for business aviation news. It's been an unattainable dream for years, the notion of supersonic flight for business and commercial applications after the retirement of the Concorde. But now NASA is working on ways to reduce sonic booms, turning them into sonic thumps that won't be as hard on the ears. I'm talking with NASA's Lori Ozorowski, who manages the Supersonic Technology Project at NASA's Langley Research Center in Hampton, Virginia, and from the Glenn Research Center in Cleveland, Ohio, Clayton Myers. He's the deputy manager of the Commercial Supersonic Technology Project. Clayton, just how close are we to creating a supersonic aircraft that can fly over populated areas without major disruption? Is this real, or is this still the stuff of science fiction?
Well, we believe the technology is available for commercial supersonic travel. The market will be larger when we will be able to fly supersonic over land. The vision of the supersonic community is a future where fast air travel is available for a broad spectrum of the traveling public. Technology improvements, including efficiency considerations, will make this happen. Lowering the sonic boom is the first step in enabling a new market of supersonic commercial aircraft over land.
Clayton, I guess we should point out that NASA isn't in the business of manufacturing or marketing supersonic aircraft, that the agency isn't competing with private corporations that want to build these airplanes either now or in the future, right?
NASA is not in competition with companies that are currently working on supersonic business class aircraft. NASA firmly believes that being able to fly over land is a requirement to support a viable commercial supersonic market, and therefore is focusing its resources on solving the sonic boom challenge. There are several early market entrant designs with the business models based on supersonic operations only over water. NASA's low boom flight demonstration mission will ensure the United States remains a world leader in aerospace technology, stimulate the economy by adding jobs in manufacturing and operations, and make it possible for airline passengers to reach their destinations in half the time.
Well, Lori, what is NASA doing to enable this new market of commercial supersonic aircraft over land? Where are we now?
Well, so NASA's aeronautical innovators are leading a government and industry team to collect data that could hopefully open the way to make supersonic flight over land possible, which in turn could then dramatically reduce travel time within the US or anywhere in the world. We have a current effort called the Low Boom Flight Demonstration Mission. That effort has two goals. One is to design and build a piloted large-scale supersonic X-plane with technology that allows us to reduce the loudness of a sonic boom to that of a gentle thump on the ground. And secondly, we plan to fly that X-plane over select US communities to gather data on human responses to the low boom loudness levels. And then we will take that data and deliver it to US and international regulators like the FAA and ICAO, the International Civil Aviation Organization.
So there's an X-plane in the works to demonstrate this technology?
Last year, NASA awarded a contract to the Lockheed Martin Aeronautics Company to build our X-59 quiet supersonic technology aircraft at its Skunk Works facility in Palmdale, California. The aircraft is designed to reduce the loudness of a sonic boom to a gentle sonic thump to people on the ground. NASA and Lockheed Martin plan to conduct the first flight tests in 2021 to prove the quiet supersonic technology works as designed, the aircraft performance is robust, and the aircraft is safe to operate in the National Airspace System. The agency will then use that X-59 aircraft to gather data on how effective the low boom technology is in terms of public acceptance. This will be done by flying the aircraft over select U.S. cities beginning in 2023 and collecting, verifying, and validating the data about how the community responds to low boom flights. We will then take that initial data set and deliver it to the international regulators in 2024. Then we will do additional community testing and deliver a final data set in 2026 for their use in considering new sound-based rules regarding supersonic flight over land, or what is referred to as en route noise, which could then enable new commercial cargo and passenger markets in faster than sound air travel.
Lori, please tell me a little bit more about this study.
There has not been a large-scale community response study in decades that involves supersonic overflight of residents in their homes. So the available data from these older studies that were done back in the 60s do not reflect significant changes in public perception of noise annoyance since these tests were conducted. The ICAO Committee on Aviation Environmental Protection, CAPE, the FAA, and NASA all are pretty much in agreement that new community response data using representative boom loudness levels in realistic environments is what's required to create limits for future supersonic overland flight standards. X-plane is needed because the next steps improving the technology for quiet supersonic flight require data from flight and realistic atmospheric conditions.
Hey, Lori, some years ago, didn't NASA conduct a series of tests that involved modifying an aircraft to change the noise characteristics of breaking the sound barrier?
In that experiment, we modified the front end of an F-5E aircraft, and during flight tests, we were able to demonstrate that a shaped shock structure could retain that shape as it traveled through a real atmosphere and ultimately lower the sonic boom loudness on the ground. That history-making accomplishment confirmed the approach to aircraft shaping, but it was only really successful in shaping the front part of the aircraft. NASA has conducted, in addition to that experiment, many wind tunnel tests over the years to measure shock structures on supersonic concepts in the wind tunnel, but wind tunnels do have issues and limitations as to what they can measure, basically because you have to hold on to that model and you can't get an accurate measurement of what's going on in the aft end of the aircraft.
Which brings us back to the demonstrator, the X-59.
So the X-59 will be the first example of an aircraft that was designed from scratch to successfully demonstrate that it's possible to lower the sonic boom signature of an entire aircraft. So only an actual aircraft equipped with the quiet supersonic technologies can be flown over communities to gather that scientifically valid public response data that's necessary for developing new rules regarding faster than air travel over land.
So, Lori, is the X-59 a prototype? Is this a version of things to come when we're talking about supersonic transport?
No, the X-59 is a one-of-a-kind experimental airplane equipped with the technologies that aircraft manufacturers may choose to include in their future designs. So I think what makes this effort especially exciting to the NBAA is that the business jet market is really envisioned to become the first adopters of this low sonic boom technology. There are a number of additional challenges that need to be overcome to allow for larger commercial transports, but overcoming the sonic boom may be enough for smaller passenger aircraft.
And by the way, Clayton, when we talk about community landing and takeoff noise and emissions issues as being important considerations, what is NASA doing in those areas as well as the areas that Lori mentioned?
Well, the emergence of near-term market entrants has spurred a need for certification standards. The FAA and International Civil Aviation Organization are engaged in parallel coordinated processes. In addition to company data, both organizations need independent analysis and trade studies data to inform the standards process. The effort is coordinated with industry for consensus on the methods and assumptions used, and the scope includes assessment of advanced procedures and technology design trades. The NASA effort also includes targeted testing and analysis to reduce the uncertainty in noise models, which include the airframe, the nozzle jet, and the fan noise. Coming up for a public release of this design study done for ICAO, we got a special session planned for SciTech in 2020 for community noise impact from supersonic transports. where NASA and I think various companies will present their results in open forum.
Clayton, how do supersonic aircraft emissions fit into this equation?
Although NASA's efforts are currently focused on addressing the challenges of quiet supersonic flight over land, NASA recognizes there are other challenges that must be overcome to make supersonic flight both environmentally friendly and affordable. Emissions at supersonic cruise altitudes is also being studied. NASA's long-term strategy includes plans for researching solutions to challenges such as takeoff noise, landing noise, and engine emissions and fuel efficiency for supersonic aircraft, and is currently working in those areas for use on subsonic aircraft. NASA's strategic goal is to prepare these technologies for use in new aircraft the aviation industry will build that will eventually make supersonic flight available to much of the traveling public.
As a child, I very clearly recall some of the tests. One, I believe, was over Oklahoma City, and I was in Oklahoma City playing in the backyard at the time, and the sonic boom knocked us off our feet. Of course, we were little kids. I take it that the technology has advanced to the point where that's not at all the kind of experience that we'll have during the next round of testing.
All supersonic aircraft designs to date, including military aircraft and long retired Concorde, create a series of shock waves in the air when they fly faster than sound. So these shock waves are generated by parts of the aircraft, including things like the nose, the canopy, the wing, the tail, and the engine inlets. Once created, those shock waves travel outward in all directions from the aircraft, and then as they're moving through the atmosphere, they tend to merge together because they're all at slightly different strengths and the air around them are at slightly different speeds, and they all coalesce into something that creates that loud boom boom that you would hear on the ground. NASA and its industry partners have matured these design tools and technologies that make it possible to design an aircraft with a different shape that alters how supersonic shock waves behave. So instead of coming together to be heard on the ground as a loud boom boom, shock waves don't merge and they actually rapidly weaken. And the result is this sound that's more like a really soft thump. So I often describe the difference between a typical sonic boom and the sonic thump that we are designing kind of like this. If you have never experienced an aircraft generated sonic boom, maybe you've heard one at an air show or you live by a military base or, sometimes they just happen by accident. I think most people around the country can probably relate more to the experience of a clap of thunder. So if you don't hear that storm coming and the typical increasing louder thunder as it approaches you, and you just hear that one clap of thunder and you're very startled by that, that's basically what an aircraft generated sonic boom might sound like.
Clap of thunder. I got it. So, what might we expect the sound of a sonic emission from the X-59 and future supersonic aircraft to sound like?
Something that's much more like that distant thunder sound. So you lose that startle effect that kind of makes you jump out of your seat sometimes, and the level is just going to be much lower. And if there's background noise and something like traffic or maybe kids playing outside, you might not even hear it at all. It may be completely inaudible. So as I've said before, the key to a much lower sonic boom comes from avoiding that merging of these shock waves as they pass through the atmosphere. Some of the design features of a low sonic boom aircraft that help reduce that shock wave structure include things like strategically locating the inlets on the top of the aircraft. You can shield the shocks coming off of that with, say, your wing structure or tail structures. You can elongate the aircraft. So you'll notice that most low boom supersonic aircraft are very long. That's some way that we spread out that shock structure. You might see a design with lots of lifting surfaces, so canards and horizontal tails, and then maybe even another horizontal tail on top of the vertical tail. So you see lots of different surfaces that are used to control that shock structure. One other thing that's become popular in looking at these designs is an aft deck, so something that shields that flow when it initially comes out of a nozzle at the back of the aircraft. All of these are things that you might see in the layout of a supersonic low boom aircraft. Another thing maybe is the external vision system. So trying to avoid shocks that are created by the canopy on the aircraft. The LBFD vehicle is actually including some external vision systems currently being developed at NASA that include cameras and sensors. And when you're inside the cockpit, you can see what's going on outside, but you don't have a forward facing window. So things like that are all different features that will help eliminate strong shocks. Over the past couple of decades, development of these powerful computational tools that we call computational fluid dynamics tools that are used to predict the flow around an aircraft have enabled us to not only do a better job of predicting that flow field, but more importantly, have allowed us to design that specific aircraft shape to reduce that sonic boom.
That's something we never imagined in the days of the Concorde, right?
We thought we knew that we could shape sonic boom signatures, but the tools just did not exist back then to be able to do that. And that's really what has driven us to the point of being able to build this X-59 aircraft.
Clayton, the sense of excitement, the sense of, man, we're on the verge of really changing aviation in a revolutionary way. You're a part of that. And I wonder if you might talk a little bit about your personal sense of wonder, joy, the things that make us all thrilled about aviation.
Well, I am extremely excited about being a part of it all. As Lori can attest, both her and I have both been working not only the commercial supersonic technology project, but also the low boom flight demonstrator project. And that's the project that's actually building the vehicle. This is the first X-plane of significance that we've had in a long time. We hope to be able to ride on future commercial supersonic aircraft. I'm just thrilled to be a part of it.
It's almost overwhelming, isn't it? I mean, just the notion that we've had this barrier, this speed barrier, beyond which we couldn't practically fly. And Lori, I guess to wrap it all up, this is really almost kind of X1 stuff.
Yeah, it's very exciting. I've worked a long career on supersonic aircraft, and I never thought we'd ever be able to solve the sonic boom challenge. My background is in aircraft design, and I had a lot of faith that someday we would be able to develop a new generation of supersonic aircraft with increased efficiency and solving some of the economic problems that happened during the Concorde era. But I just can't believe that we've actually gotten to a point where we really think we can solve the sonic boom issue. I mean, this has just been such a barrier for so long.
That's Lori Ozorowski at NASA's Langley Research Center in Hampton, Virginia, along with Clayton Myers at the Glenn Research Center in Cleveland. You can learn a lot more about how new technologies will make quieter supersonic flight possible at NBAA Base in Las Vegas. Tuesday, October 22nd from 1 till 2 in the afternoon, advances in quieting supersonic flight will be the topic of an education session. You'll find the specifics on this on the web at nbaa.org/2019. And that's the latest from the National Business Aviation Association. Remember, you can subscribe to all Flight Plan podcasts at Apple's iTunes website or wherever you find your favorite podcasts, or you can download them from nbaa.org. I'm Pete Combs. Thanks for listening to Flight Plan.